These are the answers to the study guide for Chapter 7, Section 3 and Chapter 7, Section 4. Let's take a look at the first problem here. And it says, what is the length of the slide? So you can see here's a ladder, and here's the slide, and it goes down. And so we see that the horizontal distance is 28 feet, vertical distance is 21 feet. So since we have a right triangle here, we can use Pythagorean's theorem. So this is our A term and our B term, and the side opposite the right angle is always C. So it doesn't matter which one you call A and B as long as they're connected by the right angle symbol. So my formula goes this way again: a squared plus b squared equals c squared. And I substitute, so I'll write 28 squared plus 21 squared equals c squared. So I go ahead and square the 28, and that gives me 784. 21 squared is 441, and I go ahead and add these two together, and I get 1225. And just so happens 1225 is a perfect square, because that's what I need to do is take the square root to cancel out the squared symbol. Leaves me with c equals 35. So make sure you give me some units with that. So we could say the slide is 35 feet. So let's take a look at the next problem. It says Sue places her 6-meter ladder 2 meters away from the base of the wall. And so that's what you can see here. And so they're asking how far up the wall did the ladder reach. So they're asking for this distance from this point down to this point. And so again, this distance right here is 2 meters. So what we have is a right triangle. So this time we don't have this term. We don't have one of the legs of the right triangle. I'll call that leg A, and we'll call this one B. Again, it doesn't matter which one you call A or B. The important one is C. The one opposite the right angle is always your C term. So when I go ahead and substitute into the formula this time, a squared plus b squared equals c squared, I end up having the a squared as an unknown. And then I'll write 2 squared equals 6 squared. So I'll go ahead and do some work. A squared plus 4 equals 36. And I'll need to subtract the 4 from both sides. And so a squared ends up equaling 32. And so when I go ahead and take the square root, I don't have a perfect square. And so I'm going to approximate. I'm going to round to the nearest tenth, we'll say. And so a is going to be about, and then it's about 5.7. So the way I get that is I go ahead and take 32 and I look to see what it's close to. And so you see the perfect square it's close to is 36, but also 25 is between it. So the number is going to end up being closer to 6, but it's going to be 5 and something bigger than 5.5. So 32 looks somewhere near the center, but a little bit closer to 6, so 5.7 is a good approximation. A good way to do that, we'll talk about later, is to come up with a mixed number form. So right now we'll just leave it as 5 7/10 meters. You are playing capture the football, and you are 50 meters north and 20 meters east of your team's base. And so since they're talking about north, south, east, and west, I'm going to go ahead and draw a little diagram here. So this way I can figure out where to go. So this way is north, and this way is east, and I have west out in this direction, and south down here. And so it said 50 meters north, so I'm going to go by tens here, 1, 2, 3, 4, 5, and then to the east I have to go 20. So that's that point. And so this point represents 50, or 20, 50. 20, 50 is that point. And then the next one, it says the other team's base is 80 yards north and 60 yards east. So that was 5, so this is 6, 7, 8, and then it was 60 yards east. So that's 2, 3, 4, 5, 6. So this point right here is at 60, 80. So I want to find out how far are you from the other team's base. So this is the distance I'm trying to find. So I'm going to set up a triangle here, a right triangle. So I need to find out what this distance is. So looking at these numbers a little bit closer, I have 60 and 80. Here I have 20 and 50. So you see, if I subtract these numbers, that gives me the difference that I have, and that's what I'm looking for, is the differences. So 60 minus 20 leaves me with 40. So I know that this distance is 40 yards. And 80 minus 50 leaves me with 30. So this distance is 30 yards. That's the vertical distance. And so now I'm ready to find out what that distance between me and the base of the other team's base is. So it's going to end up being this. 40 squared plus 30 squared is going to end up equaling c squared, the side opposite the right angle, which is what I'm trying to find this time. And so I end up with 1600 plus 900 equals c squared. Adding those two numbers together, I get 2500 equals c squared. So 50, and these are yards, is the distance I am from their base. Now looking at the next problem, here it asks us to classify each number. So we've got some different types of numbers. We've got real numbers, and under real numbers, we've got two types. We've got rational, and we had irrational. And under rational numbers, there are some subsets. So here are the subsets. They have integers, and so integers are special numbers that are on the number line that are positive and negative. We have whole numbers, which include all the positives and 0, and then we have natural numbers that just are the positive values. So looking at this, what we're going to want to do is see if we can take the cubic root. Well, this says a cubic root of 343 is 7. So this is a rational number, and it is also an integer. It's a number on a number line. It's also a whole number because it's a positive integer, and it's a natural number, again, because it's a positive integer. On this one, I can take the square root of 144, and that leaves me with 12. And then I can divide that by 6, but look at the minus sign. I've got to make sure I bring that in there. So this ends up being negative 2. And so negative 2 is a rational number, and it's also an integer. It is not whole because it's negative, and it's not a natural because it's negative. This number is a terminating decimal. And so whenever we have a terminating decimal, we can write that as a fraction. And so that would tell me that this is just a rational number. And that's all I need, is this part right here. Terminating decimal is just what this is. Pi is an irrational number. So that's a number you cannot write as a fraction. So you're going to see numbers that are irrational when you've got pi or the square root of something that's not perfect. So if it's not a perfect cube, perfect square, that's when it's going to be irrational. Well, here they're asking us to estimate the square roots of these given numbers without a calculator and place its value on a number line between two integers. So the way we're going to do that is I have to show the steps this way. The square root of 72 is between what two perfect squares? That's what my question is, and it's between these two. 64, which makes 8, and 81, which makes 9. So I'm supposed to place its value on a number line between two consecutive integers. Well, that's where it's between. I can tell which one it's closer to by looking at 72 and seeing which one is 72 closer to. Is it closer to 81 or is it closer to 64? And so you can find that out by subtracting. See, if I subtract these two numbers, that gives me 8. And if I subtract 81 and 72, that ends up giving me 9. And so we have 8 and 9, so I'd say 72 is a little bit closer to 8, but almost right in the center. So I would say it's about 8.5. It's probably going to round up to 8.5. So 8.5, 8.4, somewhere right in that range. So that's what I'm looking for there. And let's see here. It says to then place its number, explain how we did it. So we can just say this in words. So we say the square root of 72 is between the square roots of 81 and the square root of 64. And those are perfect squares, which equal 8 and 9. And then I can say 72 is 8 away from 64 and 9 from 81. So it is closer to the square root of 64, so which equals 8. And so a good approximation would end up being approximation is 8 5/10. It's a little bit closer to 8.4 or 8 rather than 9, but it's going to be almost right in the middle. Here it says the checkerboard is 8 squares long by 8 squares wide. The area of the square of each square is 14 centimeters squared. Estimate the perimeter of the checkerboard to the nearest tenth of a centimeter. So the key here is we want to find out what the area of one of those, or one of the side lengths is. So we know the area equals 14. So I want to find out what the side length is. So I'm going to take the square root. And when I take that square root, I'm going to look for the perfect squares it's between. So I see it's in between these two. And it's a little closer to 16 than it is to 9. So a good guess would end up being right in pretty close to the 4, maybe about a 3.8 or so. And here's a good way to do that. So I can take that 3 and then subtract 9 from 16. That gives me 7. And if I do 14 minus 9, that gives me 5. So I know it's going to be right around 3 5/7. So that's going to be somewhere pretty close to, go ahead and do that division there. 5 divided by 7 ends up giving us about 0.7. So a good approximation for this one would be about 3.7. So if I go ahead and take that, and I've got 8 of these squares, so it's a checkerboard with 8 squares long by 8 squares wide. So I'm going to do that square root, or about 3.7, and it's 3.7 inches per square, multiplied by 8 squares times by 4 sides. So this is the area of one of the squares, or at least the side length of one of the squares, times by 8 squares long, times by 4 sides is going to give me my answer. So pretty much it's going to end up being 3.7 times by 32. And so let's see what that gives us. So plugging that in, 32 times by 3 7/10 gives us about 118 4/10. And so that's a pretty close approximation of where that ends up being. So if I was to do the exact answer, I would do the square root of 14, plug that into the calculator, or not an exact answer, but something pretty close. Let's see how far off I am. So if I do 14 square root times by 8, 14 square root times by 8 times by 4, and that gives me this. It gives me 119 7/10. So if you show me on the test what you're rounding to, if it makes sense, and then do these steps right here, that would give me enough information that you knew what you were talking about. So I would take either answer. So either answer for those problems. Let's take a look at the last 3 problems that we see. It says that Sue earns Y dollars after working X hours, and her wage is represented by this function. And so here's our equation for Sue. Sue is Y equals 7.5x plus 30. So the 7.5 represents her hourly wage. So she earns $7.50 each hour. This 30 represents maybe her bonus, or just a starting amount. So she's given this $30 before she even starts working. The table shows Jan's earnings. So Jan's earnings are this. So I'll write Jan here. I'm going to find her slope, her rate of change. It's 25 minus 1250, and then divided by 2 minus 1. So I'm just subtracting the y values with the difference of the x values. And that gives me $12.50 over 1. So it tells me that for 1 hour's worth of work, she earns $12.50. So explain who's got the higher hourly wage. We'd say Jan has the higher wage of $12.50 per hour compared to Sue, who earns $7.50 per hour. So now we're going to answer the last question, which says, after how many hours will they earn the same? Same means equal. And so we're going to set their expressions equal to one another. So we have 7.5x plus 30 equals 12.5x. And so we can go ahead and subtract the 7.5x from both sides. And that gives me 5x equals 30. So when I divide by 5, that tells me that 6 hours is the time in which it'll be when they earn the same amount of money. So here it says the perimeter of these figures are equal. Find x. Okay, so if the perimeters are equal, well, I don't have to go all the way around because they're both rectangles here. So I'm going to just do half the perimeters. Since, again, their perimeters are equal, I'm going to take these two sides. So 3x and 5x, I'm adding those two together. So that makes 8x. So I just combine the 3x and the 5x. And then the negative 3 and the positive 1, that makes a negative 2. I'm going to set that equal to this. 2x and 4x makes 6x, and plus the 2. So I'm just solving for x. Again, I can do this because if their perimeters are the same, well, then their half perimeters are the same also. So I can subtract 6x from both sides, add the 2. Again, I'm adding 2 to both sides, subtracting the 6x. And I'm left with 2x equals 4. So x is 2. So it says find x and then also find the perimeter of the figures. Well, again, their figures are the same, so we found x, you just got to find one of them. So I'm going to do 2 times by 2, so I'm doing this one here, plus 4 times by 2 plus 2. And then I'm going to double that answer, and that's going to give me the way all the way around this figure. So this makes 4 plus 8 plus 2, and then times that by 2. So this makes 14 times 2 makes 28. 28 units is the perimeter. And the last problem here says the ratio of the side lengths of square A to side length of square B is 5 to 8. So 5 to 8. So this is A, and this is B. And then it says that the perimeter of B is 96. So I'm going to put 96 down here because, again, that is B. And I'm trying to find the perimeter of A, initially at least. So I'm going to multiply diagonally. So when I do that, I've got 8A equals, and I'm going to just write 5 times 96. So I go ahead and divide by 5, and I see 8 goes into 96. So I'm going to do that work there. It makes 12, so A is going to end up being 60. I get that by doing 12 times 5. But this is the perimeter of A. So now it says they want to find this area of square A. Well, if the perimeter is A, I need to find the side length. So I'm going to divide that by 4, and that gives me 15. So 15 yards is the side length. And that makes sense because 2 15s would make 30, 2 30s would make 60, so it works. So they want me to find the area. So the area is just going to end up being 15 squared, which ends up making 225 yards squared. And that's the area of square A. And that would be our answer. So those are the problems that you're going to see on this week's test. Good luck.